Okay, now you have to switch off your brain, switch it back on. We talked about in your southern oscillation. There's another oscillation, and which is more concentrated over the North Atlantic. So it's to do with the westerlies and variations of the westerlies. It's called the North Atlantic Oscillation, or NAO, and it also has two phases. Okay, a positive and a negative. So in some years you are more in the positive phase, and in other years you are more in the negative. And again, the time scale between these phases is about 2 to 7 years. Very, very, very similar. So what does it do? And it's shown here. It does not involve sea surface temperature anomalies, okay? Because we're in the colder climates, and so this oscillation is an atmosphere internal mode of variability. Okay? And what it determines, what it controls, is essentially it's where the pathway of storm patterns. Okay, more storms or fewer storms, and that has an implication on the oceans, on the ecosystems, because it influences the so-called spring bloom in the North Atlantic. I mentioned the spring. Okay, it also influences how much ice and fresh water is moved into the Greenland Sea from the Arctic Ocean. So it has other implications too related to the oceans. Also, indeed, the storm. You can have extreme events due to this. The other effects, indeed, it influences the climate on land. Okay, so it produces rain either in over the very northern parts of Europe, or more the Mediterranean region, and also influences the climate in northern America. Okay, this is what we call the North Atlantic. Okay, so now the next one is we want to also have a look at the Indian Ocean dipole, because this again has actually to do with upwelling and the variability of. Okay, so let's have a look at the Indian Ocean dipole. Yay!